So the overall goal of this project was to build a LiDAR and then test its effectiveness by attempting to map a structure on campus. So in this video, I will be explaining the creation of the LiDAR, some background knowledge about LiDAR mapping, and how I processed and created the 3D point cloud from the image processing I did. So here's some background about remote sensing. And remote sensing is just obtaining information about an object, whether it be the temperature or other physical characteristics, without directly contacting the object. And there are various forms of remote sensing such as radar, sonar, LiDAR, computer vision, but our primary focus for this project will be LiDAR and computer vision. And with my LiDAR, I will be attempting to map the bend outside of the Clark Engineering building. So I chose this target because of its unique shape and how it has like various curves and various sharp edges to it, and I wanted to see how well the LiDAR could map it. For example, I wanted to see if the LiDAR could identify like the circular shape at the top of the bend. In addition to this, the bend is also composed of two different materials, concrete and bronze, and I want to see how well the LiDAR can map the difference between the two. So now that you have some idea of what the goal of this project is, I would like to also explain some of the background knowledge about LiDARs. So for our LiDAR, we'll be using a laser as the transmitter, and the receiver will be a Raspberry Pi camera. And here is a diagram that explains how we will be calculating the distance of our point to our LiDAR. And looking at our diagram, you can see that there are some set distances that are required in order to accurately determine distance. The LiDAR also shows that moving the laser closer or further from the wall would actually determine where the pixel will show up in the image. And so by putting a clipboard or other obstruction in front of the laser, we can actually change where the laser shows up in front of the images. And this is how we will calibrate our designs. And this is my initial calibration setup. And here is a calibration graph that shows the relationship between the pixel distance to the center and the distance from the target to the camera. And from the graph, you can see that there is a distance that may be ideal to start mapping from. So this is the color picker code, and just uses OpenCV and HSV masking to simply block some of the higher HSV values in our images, and this will later be used in calibrating our LiDAR and also mapping the other objects in our LiDAR. So this image will give you an idea of how the color picker will highlight the laser line in your image. After the completion of the calibration for a single laser, we moved on to the design process for our final LiDAR. This is just a brief overview of what I use. So here's my LiDAR setup. As you can see, a Raspberry Pi, the Arduino, the Raspberry Pi camera, the line laser, and I also initially attempted to use an IMU connected to my Arduino, but it was inaccurate, so I used my phone instead. And the holder for the LiDAR was a simple 3D printed one. So similarly to the single laser, for the line laser we also calibrated it using a wall and distance measurements. With the initial calibration done, I started with some initial testing and mapping of a target, and here I just tried to map a box with a circular cylinder on top. So after finishing mapping the target and storing all the images of the mapped target onto a folder, I used a Python code that would import the images and then dissect the images for the laser line. Then all those values would be stored into a text file. Then the point cloud values are then imported into MATLAB and then translated into an image. Here you see the translated 3D point cloud with the box and the cylinder. So with the initial test done, I started to attempt to map the target outside. So to initially map the target, I simply set myself around 2 to 5 feet away from the target, and I would map each angle, and this would lead me to have about 40 images per side of the target. So the basic process would be adjusting the angle and then using the VNC server to take the image using the Raspberry Pi. So here is me just attempting to map from the back of the object, and there were some challenges with overall mapping the target. Some included ambient light, issues with networking, and reflections off the bronze. So here is the data collection code, and what it does is it creates a window that displays sort of the camera output, and then it asks the user to input an angle, and this is the angle that you are collecting data at. And then after that, the Python code captures the image and creates a file that stores the image and names it after the angle. After completing the data collection, you can use the data generation code to create a 3D point cloud. And the data generation code simply just accesses the folder with all your images you previously collected, and it applies a blur and HSV mask to them. The HSV mask was determined using the color picker code previously shown. And then after this, it will go into check each pixel and determine if the HSV value is high enough. And if it is, it will use that value to determine a XYZ coordinate and store this into a text file. And then it will do this for every picture, and this is how you generate a 3D point cloud through that image. So here is me creating the 3D point clouds for the different sides of the object. And then after doing this, I would have to stitch each of these different point clouds together to form the entire 3D object. So to stitch all the 3D point clouds together and to form the entire object, I simply had to rotate some of the initial 3D point clouds and move them until they all match the original object. And here's me just using MATLAB to display the 3D point cloud in a clear way. And here is a display of the 3D point cloud in the front view and some rotation of the 3D point cloud, as you can see. So after I completed the 3D point cloud, I attempted to create a mesh using that 3D point cloud, but I started with MeshLab, and there were a lot of issues with getting all the neighbors and the normal vectors aligned. So after spending a few hours trying to align the neighbors, I decided to use Cloud Compare instead, and I found this to be a better option for creating the mesh. So some of the things I did to improve the ability to create a mesh was to remove some unnecessary points in my point cloud and to realign some of my points to make it look more realistic to the object. Here is the mesh you see that I generated using Cloud Compare. And you do see that there are some issues with this mesh. There are some holes and blobs, and this is most likely caused by missing data points.